Welcome to my channel, viewers. We are starting with lesson number 1, class 7 Ncert curriculum. So the first lesson is properties of integers. Now let us recall the integers that you studied in class 6. First, let us remember the natural numbers. We denote them with symbol n. So natural numbers are counting numbers. They are starting with 1, 2, 3, 4, 5, 6, etc. So these numbers are called natural numbers. Then we find the whole numbers. Whole numbers are starting with 0, 1, 2, 3, 4, etc. That means the natural numbers together with 0 are called whole numbers. We remember the whole numbers on the number line. So you start with a 0, then you write the natural numbers equally spaced, the 1, 2, 3, 4, etc. Right? Now in this number line, let us say it is 0, then you put natural numbers on the right hand side equally spaced, 1, 2, 3, 4, 5, 6, etc. Now in the same way, you can imagine some numbers on the left hand side. That means you see the natural numbers are successor of 0, and if you go on increasing 1 by 1, you will get immediate successor. So successor of 0 is 1, successor of 1 is 1 plus 1 2, 2 plus 1 3. Similarly, if you consider in reverse order, that means every natural number except 1 has a predecessor. Say for example, predecessor of 6 is 5. 6 minus 1 equal to 5. Predecessor of 5 is 4. 5 minus 4, 1 equal to 4. Similarly, predecessor of 2 is 1. Now, in case of whole numbers, predecessor of 1 is 0. So 0 is the least whole number, right? Now let us imagine some predecessors of 0 on the left side. Let us imagine these numbers. Since they are also equally spaced just like on the right side of 0, so we will name them as minus 1, minus 2, minus 3, minus 4, minus 5, etc. Since they are on the opposite side of left hand side of 0, when we are considering on the right hand side of 0, we are considering these are positive integers, and when we are considering on the opposite side, left side of 0, we are considering them as negative. So negative integers are on the left hand side of 0, positive integers on the right hand side of 0. That means the whole numbers and together with the negative numbers together, they are called integers. So when we write the integers, we write 0 in the middle, then on the right hand side 1, 2, 3, 4, etc. These are positive integers. Then on the left hand side, you imagine minus 1, minus 2, minus 3, minus 4, etc. So you can say you cannot write the least integer because you do not know what is the least integer, smallest integer. You have to go to infinity. Similarly, on the right hand side, you cannot say what is the greatest integer, right? It is again infinity. So least integer is, smallest integer is minus infinity, and largest integer is infinity or plus infinity. So these are the numbers, we call them integers. Now let us think about the properties of integer. First, we will discuss a closure property. Say for example, if a and b are two integers, say a and b are integers, then a plus b is also an integer. A and B are integers. A plus B is also an integer. Take for an example minus 3 and 2, suppose they are integers. Then minus 3 plus 2, it is minus 1, right? So it is again one integer. 0 plus 1 equal to 1, it is again an integer. 6 plus 5 equal to 11, it is again an integer. That means addition of any two integers is an integer. That means integers are closed with respect to the operation of addition. Now think about any two integers again. A minus B is also an integer. If A and B are two integers, then A minus B is also an integer. Say for example 3 and 2 are integers. 3 minus 2 equal to 1, it is also again an integer. 2 minus 3 equal to minus 1, it is again an integer, right? So subtraction of any two integers is also an integer. That means integers are closed with respect to the operation of subtraction. Now think about the operation of multiplication. A multiplied by B is also an integer, right? A multiplied by B. Minus 3 suppose multiplied by minus 2 equal to 6, it is again an integer. 0 multiplied by 5 equal to 0, it is again an integer, right? Minus 3 multiplied by 1, it is equal to minus 3, it is again an integer. That means product of any two integers is also an integer, or we can say integers are closed with respect to the operation of multiplication. Now let us come to the operation of division. Now if A divided by B is always an integer, is A divided by B is always an integer? Answer is no. Say for example, you see 4 divided by 2 equal to 2, but 2 divided by 4 equal to 2 by 4. That means it is half. It is a fraction, so it is not an integer. Not an integer. That means we can say integers are not closed with respect to the operation of division, right? Division of any two integers may not be an integer. Now let's come to the property, commutative property. Say A and B are integer. A and B are two integers. Then you see A plus B is equal to B plus A. It is always true. Minus 3 plus 2 equal to 2 plus minus 3. Answer is same. Just we are changing the order. So if you change the order in case of addition, it is true. That means integers follow commutative property with respect to the operation of addition. Now think about operation of subtraction. A minus B not equal to B minus A. It is not true in case of two different integers. Say for example 2 minus 3 equal to minus 1. 3 minus 2 equal to 1. Therefore 2 minus 3 not equal to 3 minus 2, right? So with respect to the operation of subtraction, integers do not follow commutative property, right? Now think about the operation of multiplication. Say for example 2 multiplied by minus 3 equal to minus 6. Minus 3 multiplied by 2 equal to minus 6. That is 2 multiplied by minus 3 equal to minus 3 multiplied by 2. So with respect to the operation of multiplication, commutative property hold good for integers, right? Now let us come to the operation of division. A divided by B not equal to B divided by A. It is not true always. unless a equal to b. When a equal to b, then it is true. 3 divided by 3 equal to 1. Right? Now you see 4 divided by 2 equal to 2. 2 divided by 4 equal to half. That means a divided by b not equal to b divided by a. Right? So with respect to the operation of division, commutative property does not hold good for integers. So integers follow commutative property in case of addition and multiplication. In case of subtraction, commutative property does not hold good for integers, and in case of division also. Now let us think about associative property. Say a, b and c are integers. Now you see a plus b plus c equal to a plus b plus c. Say for example, you may consider two integers, say 2, 3 and 5. Now you see 2 plus 3 plus 5. Let us find this sum. 2 plus 3, 5 plus 5 equal to 10. Now let us do it different way. 2 plus 3 plus 5. First we will find the addition of 2 and 3, 3 and 5. So 2 plus 8, that is again 10. That means 2 plus 3 plus 5 equal to 2 plus 3 plus 5. So this property is called associative property. It is true for the operation of addition. Let's take, for example, in case of operation of multiplication, say minus 2, 3, minus 4, suppose. Now let's find a multiplied by b multiplied by c in two different ways. First we will multiply a multiplied by b and c. Let's see, minus 2 multiplied by 3 multiplied by minus 4. So it is minus 6 multiplied by minus 4. So it is 24. Let's do it in different way. Now a multiplied by b multiplied by c, suppose. A means minus 2 multiplied by b 3 multiplied by minus 4. So it is minus 2 multiplied by b multiplied by c. This is minus 12. Now minus minus plus, so it is 24. So answer is same. That is what we got. A multiplied by b multiplied by c equal to a multiplied by b multiplied by c. So integers follow the property of associative property in case of multiplication also, in case of addition also. Right? Now let's discuss the distributive property. A, b and c are integers. Then you find that a multiplied by b plus c equal to a multiplied by b plus a multiplied by c. Let us take an example, suppose 2, 3 and 5, suppose. Now you see 2 multiplied by 3 plus 5. So it is 2 multiplied by 3 plus 5, 8. It is 16. Now let's do it in different way. A multiplied by b plus a multiplied by c. What is a here? 2 multiplied by 3. Again a multiplied by c. 2 multiplied by 5. So it is 6 plus 10, 16. That is, we understand that a multiplied by b plus c equal to a multiplied by b plus a multiplied by c. So this property is called distributive property. That means distribution of the multiplicative operation with b and c. You are distributing multiplication with b and c. A multiplied by b and c, b plus c, you are distributing the operation of multiplication with b and c. A multiplied by b plus a multiplied by c. Now let's discuss one more property here, additive identity and multiplicative identity. Now for any integer a, you find that a plus 0 equal to a. Take any integer, minus 5 plus 0 equal to minus 5, minus 3 plus 0 equal to minus 3, 6 plus 0 equal to 6. That means identity of the integer will never change even if you add 0 with the integer. Addition of 0 has no impact. So 0 is called additive identity element. Again you see a multiplied by 1 equal to a. Any integer, take any integer, minus 3 multiplied by 1 equal to minus 3, 5 multiplied by 1 equal to 5, minus 10 multiplied by 1 equal to minus 10. Sorry. So multiplying by 1 doesn't make any sense. The identity of the integer will remain intact. Integer will never change even if you multiply it by 1. So 1 is called multiplicative identity element, whereas 0 is called additive identity element and 1 is called multiplicative identity element. Next we find multiplication by 0, any integer. For any integer a, you will find that a multiplied by 0 equal to 0. Any integer, minus 3 multiplied by 0 equal to 0, 1 multiplied by 0 equal to 0, 0 multiplied by 0 is also 0, right? So any integer multiplied by 0 equal to 0. So this is the property of 0, multiplication by 0. Just like multiplication by 1, if you multiply any integer by 1, you will find the integer, whereas if you multiply any integer by 0, you will find 0. So these are the basic properties of integers. Using these properties, we will discuss some numericals, some questions in the next video. Keep in touch.